Okay, so here we're going to do a particle motion problem. So we have a particle moving along the x-axis. Its position at any time t greater than or equal to 0 is given by s of t equals negative t cubed plus 7t squared minus 14t plus 8. So s, the distance will be measured in meters, and the time will be measured in seconds. So here's a graph of s of t. So we could see, for example, at t equals 0, we have the y-intercept of s of t is going to be 8, which we get by plugging 0 into the formula. So for example, when t is equal to 0, the particle is at the spot 8 on the x-axis. At this time, where s of t is equal to 0, that means the particle is at the position 0 on the x-axis. So that's the way s of t works to give us the different positions of the particle along the x-axis. Okay, finding the instantaneous velocity at any time t. Well, we know that the velocity, or the instantaneous velocity, is equal to the first derivative of the position function. So that's equal to negative 3t squared plus 14t minus 14, and the derivative of 8 is 0. So the instantaneous velocity at any time t is negative 3t squared plus 14t minus 14. Okay, the acceleration of the particle at any time t, the acceleration is simply the derivative of the velocity, which we can also write as the second derivative of position. So that's going to be the derivative of negative 3t squared, which is negative 6t, plus the derivative of 14t, which is 14, plus the derivative of negative 14, which is 0. So the acceleration at any time t is given by negative 6t plus 14. So for example, at t equals 0, the acceleration is negative 6 times 0 plus 14, which is just 14 meters per second squared. So at time t, the acceleration of the particle is 14. At time t equals 0, the acceleration of the particle is 14 meters per second squared. Okay, for the same scenario, we want to find out when the particle is at rest. So the particle is at rest when its velocity is equal to 0. So to find out when the particle is at rest, we take the velocity function and set it equal to 0. So we can solve this by, solve it graphically by plugging this into y1 and this into y2 and finding the intersection points. Or we could use the quadratic formula. We could use whatever we want. But if we do, we're going to find out that the velocity is equal to 0 at around 1.45 seconds and 3.22 seconds. All right, those two times where the velocity is 0, if we note the fact that the velocity is the derivative of position, and this is the position function, so the derivative of the position is 0 precisely when we have a horizontal tangent line. So at these two spots, the velocity is 0. So here t is around 3.22, and here t is around 1.45. Okay, now we want to describe the motion of the particle, beginning with where it starts. So as I discussed earlier, when time is 0, the particle is way up here at 8. So at time t equals 0, we have the x-axis here. At 8. Okay, so the particle starts off at x equals 8. I want to find out what this x value, and this x value is. And I also want to find the position of the particle at this time and at this time. Okay, to find these three x values, well, they're exactly where s of t equals 0. So these three are the x-intercepts of this function. So we need negative t cubed plus 7t squared minus 14t plus 8 to equal 0. if we solve that graphically, we're going to find that t is equal to 1, 2, and 4. Okay, so that's time 1, that's time 2, and that's time 4. Okay, the last thing that I want to do before I start to continue with describing the motion is I want to find the position of the particle at this time and at this time. So I'll plug 3.22 into the function and 1.45 into the function to find those two positions. Okay, so at this spot here where the particle is at rest, it's at the position negative 0.63 around. And at this other spot here where the particle is at rest, the position is around 2.11. Okay, so I'm going to use all this information here to describe it. Okay, so as I said, the particle starts off at x equals 8. Then as time goes from time equals 0 to time equals 1, we see that s of t is getting, the y value there is getting smaller and smaller and smaller. Then finally at 1, s of t is 0. So that means that at 1, the particle is back at 0. Or not back at 0. At 1, the particle is at 0. So then I can write the particle moves left. Okay, the particle moves left and hits the origin at t equals 1. We see now here s of t is negative, negative, negative. Then at t equals 1.45, the position of the particle is at negative 0.63. Okay, so the particle continues to move left until time 1.45. Okay, so it continues to move left until t is around 1.45 seconds, at which time the particle is at about negative 0.63. Then from time t equals 1.45 to time t equals 2, we see that the position, the x or the y values are getting closer and closer to 0. That means the s is getting closer and closer to 0. That means now the particle is moving to the right. Okay, so from time t equals 1.45 till time t equals 2, the particle is moving to the right, and it hits 0 at t equals 2. It hits 0 at t equals 2. Okay, so the particle then moves right and hits x equals 0 at time t equals 2 seconds. Then from time t equals 2 to time t equals 3.22, the position values are getting bigger and bigger. That means the particle is again still moving to the right. Okay, the y value is getting bigger and bigger, and so that means the position is more and more to the right. Okay, so the particle continues to move to the right until t equals 3.22, at which point the position is at 2.11. Okay, so it continues to move right until t is around 3.22 seconds, at which point it's at x is approximately 2.11. Okay, then from 2.11 on, the s values are getting more and more and more and more and more negative, so we can see that now the particle has switched directions, because at t equals 4, the location is now at 0. Okay, so now the particle moves to the left, it hits 0 at time 4, and continues to move to the left from there on. Okay, so it then moves to the left, hitting x equals 0 at t equals 4 seconds, and it continues to travel left for time greater than 4 seconds. Okay, so if we go through here, the particle starts at 8, hits 0, then hits negative 0.63, then hits 0 again, then hits 2.11, then hits 0 again, and then it keeps going more to the left, to the negative x territory.